Well, the newest experiment being carried out at the Large Hadron Collider is called MoEDAL. And I'm joined now by one of the team working on that, Professor Arttu Ruttanji, who's from Imperial College in London. Thanks very much indeed for coming in, Professor. Fingers crossed, so far, the Large Hadron Collider seems to have restarted successfully.
Exactly, yes. So the beams are circulating now and everything seems to be working well. And now, of course, still a lot of checks to be done, but hopefully we'll get the first collisions taking place quite soon.
OK, now your particular experiment called MoEDAL is very interesting. It's that you're working on hoping to prove something which is currently hypothetical. A particle which has only one pole. So whereas a magnet has north-south, you're hoping to find something with just one pole. So how will you know you found it?
Well, that's a good question. So yes, as you explained, the idea is to look for a particle, an elementary particle that carries just a single north or south pole of a magnet. And we have good theoretical reasons to believe that they should exist, because they would really make the theory much more symmetric and elegant. But they haven't been found before. Now, in fact, if we produce them, these are very easy to see, and especially because our experiment is specifically designed to look for these particles. So the big experiments are designed to look for other kinds of things, but with this particle, if you find one, then we're pretty sure that it is a magnetic monopole.
So what happens? You get a whole load of data, and then you pore over that data and think, that's it.
This is actually a very simple experiment where we have nuclear track detector sheets placed around the collision point, and if a magnetic monopole flies through the sheet, it will leave a distinctive mark on the sheet. So we analyze them later, and that way we will be able to tell what was going on.
And you're going over in a few weeks. Obviously, your project does for many, many weeks. But there'll be people at home thinking, well, so what? So what if you find out that it does exist? What relevance might that have?
Well, on one hand, it really has a lot of relevance for our understanding of the fundamental laws of nature. And this is really about electromagnetism, something which is very important for a lot of our technology, and really understanding magnetism properly. And so there are good reasons to believe that these particles should exist, but so far we haven't found them. And so if we can find them, I mean, there are probably going to be a lot of applications which I can't imagine right now.
All right. Thank you very much indeed. From Imperial College, Professor Arttu Ruttanji. Good luck.
Thank you.